So in this video, we're going to look at solving a quadratic by factoring. So let's start with this. Let's start with a couple key points. First thing we want to do is move all terms to one side. I'm just going to say write everything equal to 0. So we want to make sure everything is on one side, like all the variables, all the numbers, and then we want to make sure we have everything equal to 0. Okay, so set everything equal to 0. Then we're going to actually factor. So let me redo this. Okay, so then we're going to actually do our factoring. Now, once you factor, you can set those factors individually equal to 0, and then you can just solve. All right, so that's the big part, or those are the key points of solving by factoring. So let's start with this. Let's say we have, let's start out with a trinomial. Let's say x squared minus 10x plus 21 equals 0. Okay, now what we want to do here is we first want to set everything equal to 0, and you can see that's already done. So now we want to factor this. And the way we would factor this, I call this the product sum method. Some people call it like A to C factoring. You can call it whatever the heck you want. But basically, we're going to find two numbers that multiply to give me 21. But then those two numbers need to add to give me negative 10. All right? So I know that 7 and 3, if I added those together, they would give me 10. And they would multiply to give me 21. But here's the issue. This is a negative 10, so that means both of these need to be negative. All right, so then we would factor this x minus 7 times x minus 3, and those are our factors. Now, since we're solving, here's what we can do with these factors. We can split these two factors up, and we can set them individually equal to 0. Now, after we do this, I'll show you a trick, but first let's just solve this. Plus 7 plus 7. X equals 7 plus 3 plus 3, x equals 3. All right. Now, our answers are x equals 3 and 7. So that's my answers. Now, I want to back up for a minute because I want to show you a little trick you can use to finish this off a lot quicker. All right, so here's the trick. When you get your factors, it's perfectly fine to split these two up and do it the way I just did it, by just solving it out. That's completely fine. There's nothing wrong with that. But some of us like to use little tricks to make our life easier. So here's one. As long as there's a coefficient of 1 in front of this x, so basically as long as this x is by itself and there's no coefficient that we can see, then I can just take this sign and flip it. So if I flip this, it becomes x equals 7. And then I can take this sign and flip it, and it becomes x equals 3. And those are my answers. All right, now, once again, you don't have to use that trick. It's just a trick to show you how you can do this a little bit quicker. Let's look at one more. Let's even make this a little bit more complicated. Let's go 2x squared minus 2x plus 24 equals 0. Now, actually, it's minus 24. So now, if we want to do this problem, here's what we have to first check for. I see that there's 3 terms here, so I know I can use that trinomial type of factoring. But before I even consider that, I want to make sure everything is equal to 0, which it would be here. Okay? So now, what we want to do is we want to look for a GCF. There is a GCF here. It would be 2. So we're going to take that out first. So we're going to take out a 2. We're basically dividing each of these terms by 2. So that's going to give me x squared minus x minus 12 equals 0. Now, this 2 is basically going to follow our problem until the end, but now we can almost ignore 2. Don't completely get rid of it, but just block it out. We don't really need it. We're worried about the inside of these parentheses because that can still be factored. We could say two numbers that multiply to give me negative 12 and add to give me a negative 1, which would be, let's see, 4 and 3 would work here. But if 4 times 3 is going to need to give me a negative, that means one of these two numbers is going to have to be negative. And so I need to make sure I make the negative number correct so that I can end up with -1 when I combine 4 and 3. So the 4 would be negative. So now I would rewrite this x minus 4, x plus 3 equals 0. But once again, this 2 is going to come down. Now, I can split these up, these factors up, once again, just like this. And I can set each of them equal to 0. So 2 equals 0. Now, you can go ahead and use the trick for this if you want. I know I should end up with x equals 4 because I can just flip this sign. Same here, I can just flip this sign. So you can do that if you want, or I'll show you what it looks like when you solve it. We'd say x minus 4 equals 0, x plus 3 equals 0. Now, this part we would add 4, x equals 4. Okay, so we're good to go on that. Minus 3, x equals 3. We're good to go, or x equals -3. We're good to go on that. Now, this is what gives people some trouble. People see this and they say, well, what the heck is 2 equals 0? What's that even mean? Well, if you remember, if we ever end up with a number equal to a number and the statement's not true, like this is not equal, 2 is not equal to 0, it's basically no solution for that part, so we can just get rid of this. This just goes away. We don't need it anymore. So our two answers are x equals -3 and 4, and we're finished. Once again, you can use the trick for that or not. It's up to you. So let's look at a couple more. I'm going to probably do several examples on this just because I want you to be able to have access to quite a bit. Let's do an example where maybe we don't have everything equal to 0. Let's say we have x squared plus 11x plus 29 equals x plus 4. Now, if we want to solve this by factoring, we don't want this x plus 4 over here on the right side. We want everything to be equal to 0. So this is where we need to subtract x to move it over here to the left. And we also need to subtract 4 to move it over here to the left. Because now that will equal 0, and that's the trick to beginning this problem. So then this would be plus 10x plus 25. All right, so once again, if you want to factor, if you want to use factoring to help you solve, you have to set everything equal to 0. And now, this is set up for us pretty nicely. We have our three terms, x squared, x, and a number. So now we can just say, okay, what number multiplies to give me 25, or what two numbers multiply to give me 25, and add to give me 10. And we could say 5 and 5. Now, just to show you this example, I want you to notice this. These two parentheses are the exact same. So if we were to split these apart and solve each of these, it's just going to give us one answer. We can use the trick and flip this sign and just say x equals -5, or we could just write this out and say we're going to subtract 5, but x would still equal -5. Now, if we do this other side, it's going to be the exact same. So I don't write my answer and say x is equal to -5 and -5, because -5 is -5. So we only need to write -5 once. So this quadratic only has one answer, which happens from time to time. So yeah, I wanted you to make sure you see that example. Now, with every one of these, I would make sure I try these on my own before you actually watch the solution. But let's try a couple different problems. Why don't we make this a little bit harder? Let's say we have 6x squared plus 5x equals 4. Now, once again, if I want to solve this by factoring, I need to make sure this is equal to 0, but this is equal to 4 right now. So what can I do with that? I could subtract 4, and I could just move it over. Okay, so now 6x squared plus 5x minus 4 equals 0. All right, so that's our new equation. Now, let me rewrite all that just so we have it, because I want to have plenty of room, because this one could be a little long. All right, now, this is actually a unique factoring situation because we're in a little bit of trouble here. We have three terms, but right now we can't just look at -4 and say what two numbers multiply to give me 4 and add to give me 5, because 6 is in the way of doing that. So x squared needs to just be by itself. So I could try to factor out a GCF, but there's an issue with that. 6, 5, and 4. The only common factor that those share is 1. And if I factor out a 1, that doesn't change anything, because if I divide by 1, the problem's still the same. So I'm a little stuck here. Well, it's not a little. I'm stuck with 6 in front of x squared. So this is where we use a method, and some people call it like A times C. Some people call it slip and slide. Some people call it bottoms up. Essentially, every method is the same. You take 6 and you multiply it to the end. Now, we're going to act like this equals 0 is not here when we do this part. We're going to keep bringing it down, but we don't need to multiply 6 by 0. We can just multiply 6 by 4 and we're good. So we're going to change this to x squared plus 5x. And now 6 times negative 4 gives me minus 24. But then I'm going to still make that equal 0. So like I said, you just bring that part down. Now, I have removed this number in front of 6, or in front of x squared, the 6 in front of x squared. But don't forget this. Using this method is going to require us to come back in a second and divide by that 6. Because in math, it's not really a thing where you just throw 6 to 4 and multiply. The only time you can do it is if you're going to take the added step to undo it, which means we have to divide by 6 at the end. But first, we need to factor this. So we need two numbers that multiply to give me negative 24 and add to give me 5. I know since 24 is negative, that means the signs of my two numbers are going to alternate. So I want to find two numbers that have a difference of 5, basically, because that will kind of give it away. So 8 and 3 I know can work, because the difference between 8 and 3 is 5. But I want the difference to give me a positive 5, which means the 3 is going to be negative. So x plus 8 times x plus, or x minus 3 actually, equals 0. And now once again, if we divided, or if we multiplied at the beginning by 6, now we need to come back and divide by 6. Now, in previous lessons, let's first do this. 8 over 6 would reduce, let's see, that's what, 4 over 3? Yeah, 4 over 3. And then this would be 1/2. Now, in previous lessons, I'm sure you've been shown this, or if you just watched the video I did, you saw this. We would take these numbers on the bottom and we would move them to the front, right? However, you don't have to do that here, and I'll show you why. When we are factoring only, you have to move 3 to the front and 2 to the front, because factoring, you don't really want to leave your answers as fractions. Now, when you're solving, it doesn't make a difference if there's a fraction here or not. And the reason I leave the fractions is so I can use the trick to do this. I know I can split these up and set them each equal to 0, but if I want to make my life easy, I can flip this sign. So I know x is equal to negative 4 over 3. And I can do the same thing here and say x is equal to positive 1 over 2. So the reason I don't, when I'm solving, once again, I want to make sure I'm clear about this. I only do this when I'm solving. If the problem says solve, I do this. I use this trick. If the problem says factor, I don't get the luxury of using this trick. So it's all the difference. It's all about if you are solving or not, basically. So here's what you could also do. You could just set both of these equal to 0 and just solve it like we normally would. You could say x plus 4/3 equals 0, and you could subtract, and that's where we get our negative 4/3 from. You could also set x minus 1/2 equal to 0, and you could add 1/2 to both sides. So that's where we get x equals 1/2. All right, so you can do it this way if you want, or you can use the trick. It doesn't really matter, but once again, you do not have to rewrite this as moving this 3 to the front of x and 2 to the front of x. Since you're solving, you do not have to do that. All right, now you can do it if you want, but I just want to make sure you see that you don't have to. How about this? How about we do another one of those just so you can see it? All right, let's do 3x squared minus 13x minus 30 equals 0. All right, so now in this problem, once again, everything's already set equal to 0, so we're good on that. But now we want to make sure, if we're going to try to factor this, we can't just straight away go to negative 30 and try to find two numbers that give me negative 30 and add to give me 13, because this 3 is in the way. But what I could do is try to factor out a GCF. However, 3, 13, and 30 do not have a common factor other than 1. So I have to take 3 and multiply it to the end. So I'm going to write this x squared minus 13x minus 90 equals 0. Now, what I can't forget is in a second I'm going to have to come back and divide by that 3. Okay? But first I'm going to factor what I have next. So I'm going to look at negative 90, two numbers that multiply to give me negative 90, and add to give me this negative 13. And that would be 18 and 5. But then I need the 18 to be negative, because negative 18 plus 5 gives me this negative 13. So x minus 18 times x plus 5 equals 0. So now, once again, we need to come back and divide by 3. And x minus 18 divided by 3 is 6. And watch what I do here. So x plus 5 over 3. 5 over 3 won't divide evenly. However, don't move 3 in front of x. Keep it under 5. Because we're solving here, we're not just factoring. And what that allows you to do is split these two factors up, and you can use a trick to just flip the sign here. Or, once again, what you're really doing is saying x minus 6 equals 0, so x equals 6, and you're saying x plus 5 over 3 equals 0, so x equals negative 5 over 3. So you can use the trick or not use the trick, doesn't matter, but what I would do is keep this as a fraction. Keep 5 over 3 as 5 over 3. All right, let's look at a few more examples, just because we've only hit on the trinomial factoring thus far. Let's look at a couple more examples. Let's say I wanted to solve this. X squared minus 4 equals 0. Now, I could solve this one, and I could use difference of squares to solve this. Because I know x squared, the square root of that is x. The square root of 4 is 2, and there's a minus sign here, so I can make one factor x minus 2, and the other factor is now x plus 2. And I can set that equal to 0. I can split my factors up, and then x is going to equal 2, and x is going to equal negative 2. All right, let's look at another example of that. Let's say I have 9x squared minus 25 equals 0. So, once again, I can use difference of squares here. The square root of 9 is 3. Square root of x squared is x. Square root of 25 is 5. I'm subtracting. Then my other factor is 3x plus 5. Now, this one requires a little bit of work. If we split these two factors up, we can't really shortcut this, because I can't just flip the sign here and here. So this shortcut doesn't really work here. We're going to have to really fully solve both of these, which is fine. Shouldn't be a big deal. So we're going to add 5, 3x equals 5. Then we're going to divide by 3. So x equals 5 over 3. Then we're going to subtract 5, 3x equals negative 5. Divide by 3, x is going to equal negative 5 over 3. So those are my two answers now. So now, this is a good example to see, because I can't really use my trick anymore on this, which is fine. We can do it the long way. There's no problem with that. But I just wanted to make sure you saw this just so you could see it. Now, believe it or not, these are the problems that give people the most trouble. I don't know what it is about these. They're just sneaky to deal with. Let's say I have x squared plus 9x equals 0. Every year I give a test, or every year I've gone through a class with this, this is the trouble that I see missed the most, or the problem I see missed the most. But here's what we always have to keep in mind. At any point, if we can take out a GCF, we want to take out a GCF. If both of these terms, once again, we also have this set equal to 0, so it makes this a little bit easier. But as long as this is set equal to 0, if I could factor out a GCF out of x squared and 9x, then I can do that whenever the heck I want. So x and x, or x squared and x, are both the variables here in both terms. So I could factor out an x, and it would leave me with x plus 9. Now, I can split that up just like I've done before. And I can say x equals 0, and I can say x plus 9 equals 0. There we go. All right, so if I solve this, or I could also use the trick and just make this minus 9. But if I solve this, I'd subtract 9, so x equals negative 9, and x equals 0. So a GCF problem is sneaky to deal with, but hopefully that helps you see how easy it can be once you know what to look for. Like, let's do another one. Let's say I have 4x squared equals 8x. So once again, this problem gives people trouble because they look at it and they think, what the heck do I do? Well, first, let's just see what happens when we move everything to one side. So if we subtract 8x and move it over here, we would make everything equal to 0. Now, is there a GCF that I could take out of 4x squared and 8x? Yeah, there is. I could factor out a 4x. So if I do that, watch what happens. We would leave in parentheses x minus 2. We would still set that equal to 0. And now I can split these two factors up. I can say 4x equals 0, so x is just equal to 0. And I can say x minus 2 equals 0, so x equals 2. And those are my two answers. Now, I know this video is pretty long, it's pretty in-depth, but I wanted to make sure you had all the examples that you could possibly see. Factoring or solving a quadratic by factoring can be pretty intense because there's so many different ways that you could do it. Hopefully this video helps you. Once again, the main thing is after you factor, you set those factors equal to 0. That's the big takeaway here.